Hello everyone, welcome back to another video. Today we're going to be looking at the functions question from a past paper. Let's go. The question reads, the line y equals minus x plus 4 and y equals x minus 2 are the axes of symmetry of the function. The question reads, show that p equals negative 3 and q equals 1. The easiest way to do this would be to equate the axis of symmetry and then solve for the x value and then solve for the y value. Let me show you how that's done. So we'll say that the y value equals y value since it's at the point of intersection. We'll then equate the equations. So minus x plus 4 equals x minus 2. That means that x equals 3. So that point, when x is equal to 3, that is the asymptote for this hyperbola. Right? Now, let's go and look at the equation of a hyperbola and look at where the asymptotes exist. So the equation is y equals a over the x asymptote plus the y asymptote. So since we know the x asymptote, we need to write it in its correct form. So to get the correct form, we equate it to 0. So we say x minus 3 equals 0, and from there we see that my p value is minus 3. Now to get the q value, we need to solve for the y asymptote. To solve for the y asymptote, we substitute the x value that we got. So y equals x minus 2. You could choose any equation. So since we know the x value, we'll say that y equals 3 minus 2, which is 1. And that's my y asymptote. That's my q value. Let's move on. Next question says, calculate the x-intercept of f and then calculate the y-intercept of f. So what I've done is I've written out our formula completely now on the top right corner. So that's our completed formula. Y equals negative 3 over x minus 3 plus 1. Now to solve for an x-intercept, you make y equal 0. So the equation is going to be 0 equals minus 3 divided by x minus 3 plus 1. Next, we need to simplify. So you can take the 1 over and then multiply by x minus 3, leaving you with minus 1 into x minus 3, and that's equal to negative 3. We can then simplify. Minus x plus 3 equals minus 3. We can then solve for x, giving us x equals 6. So that is the x-intercept of this hyperbola. Next, we solve for the y-intercept. To solve for the y-intercept, make x equals 0. So my function is y equals minus 3 divided by 0 minus 3 plus 1. We can then simplify and solve y equals 2. So that's the y-intercept for my function. Okay. Next question says, sketch the graph of f, labeling all intercepts with the axis and asymptotes. So first I'll construct my Cartesian plane like this. So you should, in your paper, you may have a graph sheet or something like that. I'm drawing it from scratch. So next I will construct the axis of symmetry. You'll see why it's important now. So the axis of symmetry constructed would look like this. Make sure that you draw them correctly. Now you can clearly see that at the point of intersection, the point of intersection is 3 and 1, which we worked out earlier. So that is going to be where my asymptotes are going to be. So when x is 3 and y is 1. So something like this. Next, since we know the x-intercepts and we know that the a value is negative 3, we can draw in the hyperbola in the correct quadrants, like this. Clearly showing the intercepts, the axis of symmetries, and the asymptotes. All right, let's move that over to the side and look at the next question. The next question reads, write down the domain of G if G is the reflection of f along the line x equals 0. So what is the line x equals 0? That is the y-axis. So when you are reflecting on the y-axis, you should keep y the same, but change x. So my equation then becomes y equals negative 3 divided by, now we're changing the x, so it's going to be minus x minus 3 and then plus 1. Now if we want the domain of this function, you look at the denominator and we equate that to 0. So minus x minus 3 is equal to 0, which means that x equals negative 3. Now that is going to be the equation of the asymptote for g. So it tells us that the domain must be that x is an element of real numbers, but x cannot equal to negative 3. Okay, let's move on. If we want to solve for which values of x will x times f of x be less than or equal to 0, instead of writing f of x, let's write y. So as you can see on the screen, we have x times y is less than or equal to 0. Now when can we get a negative value? So when multiplying, you can get a negative value, in this case, when x is positive or y is negative, or vice versa. So we need to look at our graph and figure out where is the x values positive and where are the y values negative. So x is positive and y is negative in this region that I've drawn a rectangle around. You can see that the x values are positive, but the graph is below it's in the negative y region. So we can write out an inequality to represent that region. We can say that x must be between 3 and 6. And remember, it can be equal to 6, but it cannot equal to 3 because 3 is the equation of the asymptote. Next, we need to look at where is x negative and where is y positive. Now, x is negative and y is positive in one region, and that's the region that I've drawn another rectangle around. So we can write another inequality to represent that, and that's simply x is less than or equal to 0. Okay, let's move on. This question reads, sketch below is the graph of f of x equals x squared minus 4x minus 5 for the interval x is an element of minus infinity to 6. So it stops at 6. A and B are the x-intercepts and C is the y-intercept. The question reads, determine the value of f of 6. So pretty straightforward question. You substitute x equals 6 in your equation. So 6 squared minus 4 times 6 minus 5. That gives me 7. So f of 6 is 7. So we're going to need that for later. So that coordinate then is 6 and 7. The next question reads, determine the coordinates of A and B. Now A and B are the x-intercepts. So to solve for the x-intercept of a function, you equate it to 0. So x squared minus 4x minus 5 equals 0. We factorize, we get x minus 5, x plus 1 equals 0, x equals 5 or minus 1. Now we can solve for the coordinates. Since A is in the negative x region, A is going to be minus 1 and 0, B is going to be 5 and 0. Next question, hence calculate the length of AB. So to solve for the length of AB, let's draw it in a number line. So A is minus 1, B is 5. So if we want AB, we can say that AB is 5 minus 1. Or basically it's 6 units. Let's look at the next question. 6.4, write down the equation of G in the form g of x is equal to ax squared plus bx plus c if it is given that g of x is obtained by shifting f of x 2 units to the right and 5 units up. So there's 2 transformations happening here. Let's do the 5 units up first. So 5 units up means that y is going to equal x squared minus 4x minus 5 plus 5. So that's the 5 units up. That gives us an equation of y equals x squared minus 4x. Now, let's shift it to the right. So 2 units to the right means that y is going to equal x minus 2 all squared. And it's important. It can seem a bit counterintuitive, but it's important that you know. So x minus 2 all squared minus 4 into x minus 2. We then simplify. We get y equals x squared minus 4x plus 4 minus 4x plus 8. And then lastly, final step, y equals x squared minus 8x plus 12. All right, let's move on. Question 6.5. Suppose h is a tangent to the curve f at a certain point with a gradient of minus 2. Calculate the y-intercept of h. So they tell me that the gradient is minus 2, which means that the line must exist somewhere in that yellow region. Because remember, the slope, or remember the direction that a negative line follows. Okay, so it's got to exist in that region. So since it's a tangent, two things is important. So there's going to be one solution, right? Your delta is going to be, there's only going to be one root or one solution. And it's going to be the point of intersection of those two functions, right? So let's focus on the point of intersection for now. So we have the one equation, the straight line, y equals minus 2x plus c, right? We don't know what that point is, so we leave it as c. And we know the equation of the parabola, y equals x squared minus 4x minus 5. Now, since it's a point of intersection, we can equate them. So minus 2x plus c is equal to x squared minus 4x minus 5. We can then solve using the c and then write it in the standard form. So we're going to get x squared minus 2x minus 5 minus c is equal to 0. So that's my point of intersection. Next, one solution. Now for one solution, the delta is equal to 0. So delta, remember, is b squared minus 4ac. So minus 2 all squared minus 4 times 1, then times the last value, minus 5 minus c is equal to 0. We can then solve for c. C is equal to minus 6. And if c is equal to minus 6, remember that c is the same c value for my straight line function. So therefore my y-intercept is minus 6. Let's move on. 6.6. For which values of k will f of x minus k equals 0 have just one real root? So what we should do first is take that minus k across, giving us f of x equals k. Now, we want to look for one real root. So we want to figure out where is this line k, or where can it be drawn so that it's only going to cut the parabola at one point. So it's gonna exist in two regions. So it's going to exist one at my turning point. I've drawn that with a dotted line, and then one above that that point that we just worked out at the beginning, that point f of 6. Because since the parabola stops there, any point above it is going to cut the other side of the parabola one time. So let's figure out the turning point first. So the turning point is x equals minus b over 2a. We'll substitute minus 4 divided by 2 times 1. That means the x value for the turning point is 2. Now we want the y value. So we'll say f of 2, which is going to be k, and that's going to equal to negative 9. So when k is equal to negative 9, there's going to be one root. Now let's solve for the other region. So for the other region, when f of x is going to be greater than 7, that's when k is going to be greater than 7. So that's going to be our two values. So again, f of x will equal k and have one real root when k is equal to negative 9. So again, that's the y value of the turning point. And when k is greater than 7, Because it's only going to cut the other side or the other half of the parabola one time. Right? Remember, the right half of the parabola stops when at that point 6 and 7. So any point above that, that line is only going to cut it once. Okay, let's move on. The graphs of f of x equals minus b to the power x plus 8 and g of x equals 3 over 2x plus 7 are drawn below. Okay. A and B are points of intersection of f and g. B is the y-intercept of both graphs f and g. So write down the coordinates of B. So B is clearly, it's a y-intercept, and it's a y-intercept for the straight line. So simply, the straight line is 3 over 2x plus 7. The last value, 7, is the y-intercept. So in terms of coordinates, the coordinate is going to be 0 and 7. Let's move on. 7.2. Show that b equals a half. So b they're referring to is the exponential function, right? So we need to substitute a point, and they've given us a point a. So a can be substituted into our equation. We can sub minus 2 and 4. So 4 equals minus, and then b to the power minus 2 plus 8. Take the 8 over. Minus 4 is equal to minus, and in brackets b to the power minus 2. Let's switch them around. B to the power minus 2 is equal to 4. Let's take that power minus 2 across. Therefore, b is going to equal 4 to the power minus a half. We can solve. We get b is equal to plus or minus half. But since we only take positive values for b, we're going to say b is greater than 0. Therefore, b is equal to a half. Let's move on. Write down the average gradient of f between a and b. So we know the point for a, we know the point for b. Let's use a formula. The gradient is equal to y2 minus y1 over x2 minus x1. We know the coordinate for b and we know the coordinate for a. Let's substitute. So 7 minus 4 divided by 0 minus 2. That gives me a gradient, or an average gradient, of 3 over 2. Next question. Write down the equation of the asymptote for f. So this exponential function has an asymptote represented by the dotted line. And it's also shown in the equation. So from the equation, we can get the equation. From the equation of the exponential function, you can get the equation of the asymptote. Simply y equals 8. Let's move on. 7.5. Calculate the vertical distance between f and g at x equals minus 1. So when you're solving for vertical distance, you need to subtract the two functions. So we will subtract, we will say that the distance is equal to minus half to the power x plus 8, and then minus the straight line, so minus into 3 over 2x plus 7. We then simplify, we get minus half to the power x plus 8 minus 3 over 2x minus 7. Now we've been given an x value, so we substitute that x value in. So minus a half to the power minus 1 plus 8 minus 3 over 2 into minus 1 minus 7. You use your calculator then, and you get the distance equaling a half. The next question says, describe the transformation of f to h if h of x equals half to the power x minus 5. So this is our equation, and that's what we want. We have minus half to the power x plus 8, and we want positive half to the power x minus 5. So to change that negative half to the power x to a positive half to the power x, that's going to be a reflection in the x-axis, right? So what's happened is, if you reflect on the x-axis, you keep the x and you're changing the whole y value. So if you reflected the original in the x-axis, that minus half to the power x becomes positive half to the power x. that plus 8 becomes minus 8. Next, we want the minus 8 to become minus 5. So we need to shift the function up. And we need to shift it 3 units up. So if we shift it 3 units up, it's going to be minus 8 plus 3. And minus 8 plus 3 is minus 5. So that's basically what was done. It was a reflection on the x-axis, and then it was a translation 3 units up. Last question. For which values of x is f of x greater than or equal to g of x? We can simply solve this through inspection. We are looking for that region that I've highlighted in yellow, where the exponential function is greater than the straight line. So that little curved area there. So for what values of x, x should be between minus 2 and 0. And that's it. A bit of a long section, along lots of solutions here. If you found it useful, please consider subscribing, leave a like. And if there's something specific you'd like me to do, let me know in the comment section below. And until the next one, bye-bye.